Glass is common and prevalent in man-made environments, and poses numerous challenges for industrial and academic vision processing algorithms. In this paper, we explore the video glass segmentation. Traditional learning-based glass segmentation methods rely on RGB textures for feature extraction. These solutions often fail to adequately model the illumination and view-dependent glass features. Polarization state has proven to be a strong cue for glass segmentation in still images. However, polarization-based methods that only rely on a single-frame RGBP as input are always confused by different types of polarization instabilities or poor shooting conditions. Small changes in object orientation and/or view/light direction can induce a rapid change in polarization state. Consider the glass areas, one that show a glass door in various stages of being closed. The RGB textures remain almost unchanged, but changes in the surface normal induce a significant decrease in the angle of linear polarization, AOLP, and a noticeable reduction in the degree of linear polarization, DOLP. Similarly, moving the camera will induce a similar change in the polarization, e.g., the glass areas, too. Based on the above motivations, we propose a novel polarization video glass segmentation network, PGVSNet. Given the RGB sequences and the corresponding polarization sequences, we encode each frame into a paired set of key and value maps. Specifically, for a given modality X, we utilize Net50 architecture to encode the modality, and the key feature map of each frame is derived using our specially devised polarization-guided integration module. For memory frames, the value map is generated through a ResNet18 model and a convolutional block attention module, CBAM, in the value encoder. Relying on query key and the pairs of memory key and value maps, PGVSNet endeavors to estimate the value map. Before the decoder stage, we introduce a cross-modal temporal attention module, CMTA, to model the short-term interactions. In the decoder stage, the query frame can benefit from the preceding memory frame polarization cues via the polarimetric temporal forward, PTF, module. The polarization-guided integration, PGI, module leverages RGB sources and polarization cues as guidance to combine multimodal key feature maps for each frame. Specifically, PGI employs a convolution layer, followed by a regional pooling operation, output size equals 11, and an additional convolution layer, a matrix multiplication to fuse different modalities. The CMTA module is proposed to capture rapid changes across trichromatic information modalities over short time intervals. Central to our CMTA module is a multi-head self-attention mechanism applied along the modality dimension and then extended to the temporal dimension. The polarimetric temporal forward, PTF, module engages feature B1 and feature B2, sourced from the query and the preceding memory frame, as inputs. PTF first carries out an unfolding operation on these inputs, then performs two-stage element-wise multiplication to fuse different polarization features. We introduce a novel RGBP video-based dataset, PGV117, which is collected in various indoor environments. PGV117 captures both static and dynamic scenes. We randomly pick one of 5 predetermined camera motion patterns: front, inclined, circular, straightforward, and up-down. Here we introduce our experiments, multi-view polarization consistency. These figures illustrate the correlation between variations in DOLP and the corresponding MIOU, compared to single-frame polarization-based PMRCNN and PGSNet. PGVSNet is specially designed to leverage and aggregate temporal changes in polarization cues. Next is the qualitative comparison. PGVSNet against the state-of-the-art image-based glass segmentation and video detection and segmentation methods. We retrain all methods on the PGV117 dataset and evaluate them on the 32 test sequences. We validate the impact of each component in PGVSNet by disabling one or more components and comparing the performance on the PGV117 test set.